Calculus. The area of a healing wound is given by A equals pi r squared, where r is the radius length of the wound. Now hopefully you recognise pi r squared as the area of a circle formula. So A equals pi r squared would give us the area of a circle, and the r representing the radius is the distance from the centre to the edge. So the radius is the distance from the centre to the edge. Now you don't need to know much about the area of a circle formula for this question, but it's good to recognise it when it comes up. So the area of a healing wound is given by A equals pi r squared, where r is the radius length of the wound. So imagine that this is a wound. The radius length is decreasing at a rate of 0.5 millimeters per day. So obviously the wound is getting smaller day by day by day. So this shape is getting smaller. And the radius is also getting smaller as the wound heals. So as the wound heals, as this circular wound heals, the circle itself gets smaller, the area of the wound gets smaller, and likewise the radius gets smaller. So the radius is shrinking, and it's doing that at a rate of 0.5 millimeters a day. So we're interested in finding how fast the area is decreasing at the instant when the radius length is 10 millimeters. So when this radius length is 10 millimeters, we're interested in how fast the area is decreasing. So what we're going to do is start off with A equals pi r squared, and we're going to differentiate A with respect to r. We're going to find dA dr, the derivative of A, with respect to r. So what we do is bring the power down in front and reduce the power by 1. So bring the power down in front and reduce the power by 1. Bring the power down in front, so we get 2 in front of the pi r, and reduce the power by 1. 2 minus 1 is 1, so we have 2 pi r to the power of 1, or just 2 pi r. So the derivative of pi r squared is 2 pi r. So what we found when we found 2 pi r is the rate at which the area of the wound is changing with respect to its radius length. So this is the rate at which it is changing. Now we were told in the question that the radius length is decreasing at a rate of 0.5 millimeters per day. So dr dt is going to be 0.5. So if we were to differentiate r with respect to t, we would get 0.5. Now we were not actually given what that was, we were just told it in the question. So the radius length is decreasing at a rate of 0.5 millimeters per day. So we're told it in the question, we did not have to work that out. So what we want is dA dt, the rate of decrease of the area. So that's what we're trying to find. How fast is the area decreasing? So we're trying to find dA dt. We want to differentiate A with respect to t. So using the chain rule, that means we're going to multiply dA dr by dr dt. Now we got dA dr to be 2 pi r, and we were told in the question that dr dt was 0.5. Now they didn't tell us that it is dr dt exactly, but they told us it was the radius length was decreasing at this rate. So that's how we know that dr dt is 0.5. So differentiating r, the radius, with respect to time. Differentiating the radius with respect to time. Radius per day, radius per time. So dA dr is 2 pi r, and dr dt is 0.5, and multiply them together. 2 multiplied by a half is 1, because a half of 2 is 1. So technically we get 1 pi r, which we can just call pi r. So we were interested in when the radius length is 10 meters, 10 millimeters. So all we have to do is sub in place of the r, 10. So it's going to be pi multiplied by 10, because the r is going to be 10, and that's just going to be 10 pi. So dA dt is going to be 10 pi millimeters squared per day. So how fast is the area decreasing at the instant when the radius length is 10 millimeters? It's decreasing at 10 pi millimeters squared per day.